Okay, yeah, so this is the question. In the figure, masses m1, m2 and m are 20 kg, 5 kg and 50 kg respectively. The friction between m and ground is 0, and friction coefficient between m1 capital M is and m2 and ground is 0.3, which is same. So it is 0.3 here, this is 0.3 here. Two strings are massless, so strings perfectly horizontal between m1 and p1 and m2 and p2. It's perfectly vertical between p1 and p2. So these are the general information. The external horizontal force is applied to the mass capital M. So this is a force acting on this one. Okay. G is 10. Okay, now let's start. So draw FPD for M, clearly showing all the forces. So let's draw the FPD. Let's start with M1 block. So this is M1 block. We have it has tendency to move to left. The friction will be on the right hand side. Let's assume that is F1. There's a normal M1. There's a M1G. Okay, let's talk about the capital M block. So capital M, the forces on capital M. That reaction of this one will be there, and there are two pulleys connected. Okay, because of these two pulleys there will be tensions here, down, upward and the left, and again there will be a normal and there is an mg, and there's a reaction of this one which will be downward, and obviously there is a extra force. And M2 block, we have a tension, so it has tendency to move right, so the friction will be on left. So M2 and this is M2G. Okay, fine. So these are the forces acting on all the blocks. So I think this is the done. This is done. Okay, so let's see the B part. The magnitude of the friction between M1 and capital M is F1, and between M2 and capital ground is F2. Okay, so here friction is F1 and here it is F2. For a particular F, it is found that F1 is to F2. To find value of F1 and F2 and the acceleration of the system. Sure. Okay, so here first we'll find the limit of frictions of the F1 and F2, the maximum value. The F1, so when you have F2, let's say, the F2 will be like mu into N2. Mu is 0.3 and M2 is M2G. So M2 is given as 5, so it makes it 15 Newton. And similarly, if we calculate F1, which is mu N1, so mu is 0.3 into M1G. M1 is given as 20, so 20G is, which makes it, 16 Newton. So this is F1. So now we have to find F tension and the acceleration of masses. So here it is said that for a particular F, it is found that F1 is equal to 2F2. So here F1 value is 60 Newton, which is obviously is greater than F2. So if a system is moving, let's say, right, with M block, capital M, small m1, if they are moving, so which means there is a relative motion between M2 and ground. So there is a maximum friction acting. Okay, so if we assume that system is moving, okay, which obviously will move because there is no friction between M and the ground, so M2 will also move, and on that's why that on M2 the friction will be 15 Newton. That is the there, okay, because the system is moving and system moves, so which means like kind of friction acts. So here kind of friction and limited friction both are same. So here the value of F2, which is clearly 15 Newton because M2 is moving. Now if F2 is 50 Newton, so which makes F1 30 Newton as per the given condition. Now F1 is 30 Newton and the maximum value of F1 is 60 Newton, which means this is a static friction in nature. So between M2 and the ground, there's a kind of friction is acting. Between M1 and capital M, there's a static friction acting. So which means these two systems, M1 and capital M, are moving together. There's no relative motion between them. So here we'll assume that they are moving together. Okay, now if they are moving together with a certain acceleration, so what is the acceleration of M2? So here we are going to find the relation between accelerations. So if they are moving with A1 acceleration and m2 is moving with a2 acceleration. So here we'll apply the string constraint. So that length of the string L1, this is L2, this is L3. So if we see the total length of this string L1 plus L2 plus L3, which is gonna be constant, right, because of inextensive property. No, the length of L2 is always constant because it's the distance between these two pulleys, and that is not going to change. So we can say that change in L1, basically change in, like we can write as dL1 will be equal to dL3, and that is obviously minus sign will come. This one is increasing, so other one will decrease, right? You can see from the diagram. So because of this thing, the acceleration of these two will be same. So that is the conclusion. The acceleration A1 is gonna be equal to A2. So we are assuming that is A, let's say. Now we're going to write the equations. So if we write the equation on M2, let's say first. So on M2, we have tension here, we have friction F2, and that's moving with A acceleration. The equation is T minus F2 equal to, which is 5 into A. Now F2 value we know, which is 15 Newton is equal to 5 into. So that is the first equation which we are getting. Okay, now second equation. So here the system M1 plus capital M are moving together. So that's moving with the A acceleration. So system, both the blocks M1 plus capital M are moving together. So there's a force F on the system. The friction will be internal force. So this is the system. So these two tensions are also internal force. This one and this one, right? So this is the force which is acting on the system, external force, right? As an external force. So this is the external force. This is the external force. So we'll consider these two forces here, and there's no friction between them. So and that is moving with A acceleration. The equation will be F minus T is equal to M1 plus capital M, that is giving us 70 into A. Now if we use these two equations, if we add them, so we'll get F minus 15 is equal to 75A, and there's the equation F equal to 15 plus 75 into A. That's it. Now here we need equation, the value of acceleration, so this can calculate capital F value. For this one, if you see this M1 block, the M1 block is moving with A acceleration, right? So if we see M1 block separately, now there's a tension on this one T, there's a friction which is 30 Newton, right? The friction, and it's moving with A acceleration. So if we write the equation, the 30 minus T equal to, and the value of mass is 20 here, 20 kg. Now if we see these two equations, so this is the equation 2, this is the equation 3. Now if we see 1 and 3, so 1 plus 3, if we add them, we will get 30 minus 15 is equal to 25A. So A is coming as 15 by 25, which is 3 by 5 meter per second square. Correct? Now this is acceleration we'll use here. So F is equal to 15 plus 75 into 3 by 5, which is 45 plus 15, which is 16, and that's the answer. That's the value of force as per the answer. Now we will find the tension also, so we can use any of the equations. So I'll use the equation 1 to find the tension. So T is equal to 15 plus 5 into 3 by 5, which is making T equal to 15 plus 3 equal to 18. Now that's the another answer, T equal to 18. So I think every answer, every value we got it. So that's it. Thank you.